Okay, to get us ready for some of the other steps needed to understand other step growth or polycondensation reactions, we have to have a crash course in organic chemistry. We've seen that the R group can be used to represent molecules that otherwise would distract us from the needed reactions. We saw that in the initiation step a moment ago. So in general, organic chemists use the capital R as a chemical shorthand to represent some undefined, often carbon-based structural fragment. We do this because it shifts our attention away from the unimportant features of that molecule and draws our attention to other specific steps, like we wanted to see for the radical transforming reactivity to the mer that is added by initiation in polyethylene. Okay, so to help us recognize how we make polyesters and polyamides like nylon, we need to recognize some functional groups. An alcohol group is going to have a carbon linkage and some carbon structure, and it'll contain an OH group, an oxygen and a hydrogen group. Okay, an ether is like a symmetric version of that in that there's a central oxygen singly bound on either side, and there's carbon fragments to either side. The aldehyde is here because we've seen its importance in formaldehyde. So where R is equal to H, we have formaldehyde. And so the aldehyde functional group is the 2/3 of that formaldehyde unit shown there. A carboxylic acid group, these are needed to make polyesters, very important functional group for step growth polymerization. And so the carboxylic acid involves a carbon-oxygen double bond and an OH group at left, and then some carbon fragment to satisfy bonding at that carbon. The ester is very close to that in that the OH group that was at the right position here is now modified to have another carbon fragment. And so the ester group is often found in the main chain of polyesters and is responsible for some of the unique properties in those materials. Nitrogen-containing groups that we need to familiarize ourselves with amines. These are, if you want, the nitrogen version of the alcohols that we saw a moment ago, in that they react in many of the same ways, except that their number of hydrogens is going to be different, of course. So a primary amine is going to have 2 hydrogens and 1 carbon fragment, and a secondary amine is going to have 1 hydrogen and 2 carbon fragments on either side of it. And amides, typically the ones we see in polymers, are shown here. So here is a amide that would be useful for considering for nylons, for example. And the amide is the hybrid, if you want, of a carboxylic acid and an amine. Okay, so it involves that C double bond O from a carboxylic acid, for example, and it involves an NH from an amine, and we see those singly bound right here. Okay, so these are important groups that you need to memorize, and it's going to be important to use when we try to understand the steps for growing polycondensation polymers like polyesters and nylon.